The balancing shortcut is a great way to solve weighted average and mixture problems without algebra. I'm Mark Clinton, the GMAT mentor, here to make the GMAT make sense. So here we're told that a mixture contains 2 pounds of chocolate for every 3 pounds of peanuts, and the average cost of the mixture is $3.80 per pound. We're also told that chocolate costs $2 more per pound than peanuts, and then the question asks for the price of the peanuts. So to solve this a smart way, I like to draw a balance scale, and we know that the chocolate is the more expensive price, so we'll put the chocolate on the right and the peanut price on the left. And then we know the average has to be in between those two prices. The average is $3.80, so we'll put that in the middle here. But I actually put it a little closer to the left side, and that was on purpose because we know there's more pounds of peanuts than pounds of chocolate, right? So the average is weighted towards the peanuts. So that's important, and then we also want to include this $2, right? So in other words, there's a total distance or difference of $2 between the peanut price and the chocolate price. Okay, now the question here, of course, is what is the distance between the $3.80 to the peanut price and the $3.80 to the chocolate price, okay? And so here's the key insight. The ratio of those distances is the same as the ratio of the pounds, which is 2 to 3, right? The 2 pounds of chocolate to the 3 pounds of peanuts. The only difference is it's going to be flipped. So the 2 pounds of chocolate becomes 2 units of distance from the peanut price to the average, and then the 3 pounds of peanuts becomes 3 units of distance from the chocolate price to the average, okay? So now we have a total of 5 units of distance across these two prices. That's equivalent to the $2 of distance that we saw earlier, right? So we know that, in other words, that it's going to be $2 for every 5 units, right? So if we do that division, that's the same thing as 40 cents per unit. And now we can figure out those distances. So the 2 units times the 40 cents gives us 80 cents, which means that the peanut price is $3.80 minus 80, which is $3. And for the chocolate, we know 3 units times 40 cents gives us $1.20. So that $3.80 plus $1.20 gives us $5 for the chocolate price. But of course, the question was asking for the peanut price. So the answer is E, $3. And this is really a great way to solve this once you get used to how this works. So this relationship is always true. Whenever you have a weighted average or mixture with 2 components, the ratio of the quantities is equal to the ratio of the distances from the average, but flipped. And this is usually the best way to solve. However, you can also solve it algebraically using the average formula. So to use the average formula here, we need totals over totals, in this case, total cost over total pounds. So we'll write that down. And that's going to be equal to the average, which is $3.80 per pound. And since we have that ratio of 2 pounds to 3 pounds, let's just make our lives easy and pick 2 pounds and 3 pounds, right? So we'll say the chocolate is 2 pounds and the peanuts is 3 pounds. Now, of course, you could also pick 4 pounds for chocolate and 6 pounds for peanuts, or 6 and 9, etc. But again, make our lives easy, pick 2 and 3 here. Now we also want to indicate the cost. Now again, the peanut cost is the cheaper cost. So let's just go ahead and call the peanut cost, let's just call it P, okay? And then the chocolate cost is going to be P plus 2 because it's $2 more. And now we can plug this into our formula. So the chocolate is going to be 2 pounds times P plus $2 per pound. The peanut cost will be 3 pounds times P dollars per pound. And then we have our total pounds, which is 5. Again, that's going to equal 380. And now we just simplify, right? So we can multiply that 2 times P plus 2 times 2, and then plus 3P. And then let's just go ahead and multiply that 5 on both sides. So that gives us 380 times 5, which we can simplify, right? 3 times 5 is 15. 80 times 5 is $4. So we have a total of 19 there. Then we can combine like terms. So we have 5P plus 4 equals 19. Subtract 4 from both sides. 5P equals 15. And then divide both sides by 5, p equals 3, which again gives us the answer of E. So again, this is a totally workable way to do things. And in this case, not that much more difficult than the average shortcut. But again, I still would strongly recommend learning that shortcut because once you get used to it, it is faster, it's less prone to error, and will work in the vast majority of cases. Sometimes actually this standard way will not work and you have to use that shortcut. And in fact, once you get used to the balancing shortcut, you might be able to solve without even drawing out the scale itself. So it is a very useful shortcut and I strongly recommend using it. So hopefully that helps the GMAT make sense.